Okay, so for vector plots, we can have on the center plane. So let me create again the center plane, and it is from the post processing menu and from the create, and click on the iso surface, and from here I will choose the not anything here, but from here mesh as coordinate compute, and put the value 0 as, because 0 will be the center plane of the your pipe. And after that, click on the vector, click on edit or new. So you can create multiple plots for the vector and in the new windows. So let's say it's the first time, so I'm going to choose the edit, and from here I will click on the x coordinate, and depending on direction of the flow, so this is the inlet from this side, from left side to the right side. You can zoom the whole geometry from here, and you can minimize these windows, these panes, and here we have the vector plot. And as you can see here that because the boundary is developing on the upper surface, as you see here, so that's why to keep the same flow rate from inlet to outlet, it has to increase the velocity, because area is decreasing throughout the pipe because of boundary growth. So it has to increase every velocity at the outlet to keep the same mass flow rate, because the equation for the mass flow rate is the density times area times the velocity. And in this case, because the flow is incompressible, therefore the density will be constant. So at the expense of the area decrease, the velocity will have to increase to keep the same mass flow rate throughout the pipe. And so velocity here is around, in the center plane is around 1.89. It should be typically 2, because for laminar pipe flow, the maximum velocity which is in the center point, so center location, it should be twice the every velocity, which is 1 meter per second at the inlet. And second thing is, you can notice here that after some distance, the axial velocity is now constant. And by definition, when the axial velocity gradient is now changing throughout the length, the flow is said to be the fully developed. So flow is fully developed after certain length here. And now I want to create the different section planes along the pipe length. So this time I will be using the z coordinate, because I want to create the planes along the pipe length in this way. So they will be normal to the wall of the cylinder. So they will be planes parallel to the inlet and outlet faces and throughout the length of the pipe. So I will create these planes at the length of, so choose the z coordinate and put the iso value as the, let's say 1, because length of pipe is 8 meters, so 1, then 2, then 3, then 4. You can also put the name of that particular coordinate. Let's say you want to put here as the 5 meter. So you can recognize the name just from looking at the plane name here. So now you can see that the z 5 meter means that this is plane at the 5 meter of the z coordinate. And similarly, you can put the value 6 and then 7. And from the manage option, you can rename also these all coordinates which you have created previously. So you can just rename here. So let's say I put the here one as the z 6 meter. So rename, and the new name will be the 6 meter. Similarly, you can change the name of these ones. And also, if you want, you can delete these from your fluent case file. So you can delete them also. And you can see that how many points are there, 1D facets, 2D facets, and the zone ID you can see for every zone here. Let's say here. So every zone has the unique ID. And from here now you can go to the contours. You can hide these all things from here. And now you can display the, let's say, pressure along the center of the pipe. So our center are maybe throughout the length of the pipe. So I can choose these z coordinate planes, not the x ones, and I can display the pressure along the length of the pipe. and you can uncheck the global range, so this will display the local values on the each of these cases. And also now you need to change the lighting also. So I will go to the from viewing options and lights here. Over here you can also change the lights from directly from here and click on apply. So you can now observe lighting has been changed. If I uncheck the box and again apply, so light, now this is dark here like this. I can off the lighting method. You can choose the go out method, something like that. You can uncheck these boxes and this will also affect the lighting system here. I can go for the one and uncheck box and apply, so this will change the lighting system here. So I can display the pressure contours. So let's say we choose a global one like this, and so on the every plane we have some unique values, and you can also display the values on the inlet outlet like this. And you can also display the velocity control plots, and you will see that in the center plane we have the maximum velocity, and on the outer side of the plane we have the minimum velocity. This is because of the boundary layer. And you can also display the vector plots on these settings. So you can plot on the center plane. You can plot them also on these new coordinates, which are along the z-axis in this way. And you can also plot the path lines, and you can release them from any plane you have just created. So let's say if I release from the z is equal to 5 meters, so just display the mesh in the just outline like this, and click on the display. So it's just releasing the path lines from this plane. You can skip some path lines. So you can skip the, let's say, 4 path lines, and the 5th one will be displayed in this way. And also you can have the continuous mode. You can pulse them, so from the single to the multiple. So it will show you how they are traveling through the length of the pipe. Stop here. You can make it continuous and pulse. So full lines will be pulsing at some pace. Stop here. And then you can, this is a continuous, this is a single one, and you can also display the line arrows. So this will show you the path lines, also the direction of these values. You can change the attributes. So I can change the scale, let's say, to the 0.1, and this will coarsen the path line in this way. And you can change the multiple parameters here to display in a way you want to have. So I can put the width as a 2 and again display. So the width of the lines are now, they are double the size of the previous one. I can change the spacing factor, let's say it's 0.1 or 0.2, and now display. So the spacing factor is basically about the number of these arrows. So if I put the value as a 2, let's say, so you have to play with these parameters. So now you can see that the arrows are now, they are the distance apart. So there are very few arrows along the one path line, and you can make it, let's say, 0.5 and scale to the 2. So just play with these parameters to see how they are affecting your post-processing and the visualization. So I can go back and make it scale as a 0.3. Okay, and again display. And you can also release from the inlet and display. And you can observe here that we are just have up to the center plane or the middle of the pipe, more likely. So this is the problem with the path line, because now the length is not completing the whole domain. In this case, you have to either increase the size of the step, that is step. So the whole length we are getting is right now with a 0.01 into 500. So it's equal to 5. So it's only traveling up to the 5 meter of pipe length, but the whole length of pipe is 8 meters. So for that case, you have to either increase the steps to the 800, and this will be enough to cover the whole pipe distance on a screen. If not, then you have to increase the size, step size, maybe 0.05. This will do the job. Yes. So you can see that we have the path lines going in this way.